particle is in linear simple harmonic motion between 2 points A and B, 10 centimeter apart. So it means you have A and B. It's 10 centimeter apart. Take the direction from A to B as the positive direction. Give the signs of velocity, acceleration, of force on the particle when it is at the end A. So when you are at end A, right? So what will happen? Signs of velocity. So that means when this is at end A, velocity will be 0, right? Acceleration will be this direction, right? So the recovering force is, this is the mean position. So that means the acceleration is in this direction. So the acceleration should be taken as positive. Force is also same as acceleration, which means force is also positive. At the end B, so when you are at this end, again the velocity is 0. If it's 0, I cannot say whether it is positive or negative, right? So I simply have to say 0. Acceleration, it's trying to come this side, which means acceleration is negative. Force is same as acceleration, which means it's also negative. Okay. At the midpoint of AB going towards A, you see when the particle is the midpoint of AB going towards A, which means it's moving this way. It can be coming here and then coming back here. So it will be in the same position, but in that case, it will be going this way. So here they are specifically saying when the ball is going this way towards A. So in this case, velocity will be maximum. So what can you say about the velocity direction? It's this way. We said A to B is positive, so this should be negative. Everyone okay, Ashwin?
Yes, sir.
So Usma, can you tell me what will be the acceleration, positive or negative?
I think it's positive, sir.
Positive. And Kita, what do you think?
No, it's negative.
Negative?
Yes, sir.
It's negative.
Well, what I'm thinking is, what will be the displacement here? X is equal to midpoint means X is equal to 0. Do you agree? This side is positive, this side is negative. Right? So which means acceleration will be minus omega squared x, which means acceleration at this point will be 0. Okay, in the midpoint. Force will also be 0. Why? Because only when the pendulum is here, there is a force to pull it back. When the force is here, right, when the pendulum is here, there is no force to pull it back, which is already in the mean position, which means I think I should take the force as 0. Does that make sense, Ankita?
Yes, sir.
No?
Yes, sir.
Okay, then what about force? Force is also 0. Okay, we talked about it, so that means this is over. So once you understand these first 3 things, I think all these things are going to be easy. So let's try this one. So 2 centimeter away from B going towards A. So I don't have enough space here, so I'm going to redraw this. So take down this properly. Okay, so this was question A, this was B, this was C. Okay. Now we are going to D. So you have ball here and you have ball here, so A and B. Sorry, you have point A, you have point B. But they said 2 centimeter away from B going towards A, which means it's here. They said 10 centimeters is a gap, which means 5 centimeters is a gap in the one side. So this is 5 centimeters. This is 5 centimeter. They said this is 2 centimeter. So Ashwant, tell me the velocity. It's going this way. So velocity is positive or negative?
Negative, sir.
Negative. Very good. Acceleration. When the pendulum is on this side from the mean position, it's trying to come this side. Acceleration. So if it is trying to come this side, what do you think?
Negative.
Positive. Negative. Very good. Force is also negative because acceleration and force will be the same. Okay. 3 centimeter from A going towards B. 3 centimeter from A going towards B. So Uzma, can you tell me velocity?
Velocity positive, sir.
Positive. Okay, very good. Acceleration? Positive.
Positive.
Force?
Force also positive. Positive, sir.
4 centimeter away from B going towards A. 4 centimeter away from B, which means it's going to be somewhere here. Going towards A. Right? So now tell me, Ankita.
So the velocity will be negative,
Okay.
and the acceleration will also be negative.
Okay.
Force also negative.
Okay, very good. So it's very similar to this one, right? So because it's on this side. So negative, negative, negative. Okay, very good. So if you make the drawing like this, and if you think, it's very, very easy. Okay, as I always say, drawing is the language of engineers and scientists. If you don't make a drawing and if you're trying to solve this problem, it's very, very wrong way to do it. Okay, let's go to. Which of the following functions of time represents simple harmonic motion? Periodic but not simple harmonic, non-periodic, give period for each case of periodic motion. Omega is any positive constant. Okay, how to do this? So let's see. You know that the simple harmonic motion characteristic equation is A is equal to minus omega square into x. So sin omega t, cos omega t, these things will be simple harmonic. So I can look at the sine and cos. I can say whether it is simple harmonic or not. So what do you think? Sin omega t, cos omega t. So we said y is equal to a sin omega t, right? So it can be a combination of sine and cos also. So this is more like a mathematical question. Okay. So omega is there, sine and cos is there. So I think this will be periodic. They are asking you to find the period, which is time period. So time period t is equal to 2 pi by omega. So if you plot sine cube omega t, right, these kind of things can be shown in Excel sheet. Okay, I'll try to show some Excel sheet later. So when you plot the sine curve, it looks something like this. But if you plot the sine squared term, I told you somewhere else, it looks something like this. Okay, listen carefully. You see, in sine term, you will get both plus and minus. But when you do sine square, so you see, this is sine omega t. This is sine squared omega t. The square means you know that everything will become positive. So that means there's no negative. Okay. So the interesting thing here is it is periodic, right? So this will happen at a particular period. But the thing is, it is not a simple harmonic motion. So the same thing is applicable for sine cube. So when you multiply this with sine, right? So this into this, you will get some side, and then this will be minus into plus. Okay, so I think I made a mistake here. Sine square omega t should be looking. So this, if I square it, it will go something like this. If I square this minus into minus, it will become plus. So it means it will go something like this. This is again plus square. This is again. See, I don't have enough space, so that's why I'm kind of struggling. So this goes with this goes with this. So this is what a sine squared omega t looks like. Sine omega. So this is also periodic, right? But then it is not simple harmonic motion. Why? Because when you plot, when you try to calculate this, if you go back and check your notes, we said y is equal to a sine omega t. We said velocity is equal to a omega cos omega t. Then we said acceleration is equal to minus a omega squared sine omega t. I don't remember this. Ashwant, do you remember?
Sir, no.
No. Because you not studied the theory. What about Mithun? Do you remember?
Yes, sir.
Remember? Okay. So that means what did we say? A is equal to minus a into sine omega t will become y. That is why we said acceleration and displacement are proportional with the negative. So this is the characteristic equation of simple harmonic motion. If you try the same thing with sine cube or sine squared, you will not get this kind of form. Okay. Again, as I told you, unfortunately, this is a mathematical question. Okay. Only if you know differentiation, you will be able to do this. Okay. For now, I'll just work it out. A sine cube omega t. They did not give you any k amplitude, so I'm going to this 1. So velocity is equal to dy by dt. So that means it will be 3 times sine squared omega t into by chain rule I have to differentiate. So omega t, which means it will be omega. Sorry, by chain rule I will be differentiating the sine. So when I differentiate the sine, I will be getting cos omega t. Then when I differentiate the omega t, I will be getting omega. Similarly, if I differentiate this one more time, acceleration, it will become UV method. Okay. Unfortunately, you don't know all these methods. Okay, it's coming in your differentiation in your 12th standard. So for now, I would say that this will not form like this. So since it will not get an equation like this, it is not harmonic. It's not simple harmonic. So it's periodic, but it's not simple harmonic. So take it down. This will be periodic. So this is simple harmonic. First one. Whereas this is periodic, but not simple harmonic. Two pi by omega is the same thing, time period. Yes, since this is omega, time period is 2 pi by. This is a straightforward question. Whenever you see cos something, right, you can say it is a simple harmonic motion. 3 cos pi by 4 minus 2 omega t. So whenever you see sine or cos, immediately you can say it is a simple harmonic motion because it will come to this situation. Okay. So this is simple harmonic motion. This is a phase angle, so you don't have to worry about this number. So you take only this whatever is in front of t. So that means time period is equal to 2 pi by omega is the usual formula. But in this case, it is actually not omega, it's 2 omega. So that means in this particular case, I will be writing it as, so this is a usual formula. But in this particular case, I should not put omega, I should put 2 omega. So it means 2 pi by 2 omega. So 2 cancels, so I'll be getting pi by omega. Okay. Again, if you are wondering, sir, how do I know this? Well, unfortunately, I don't have an answer. As I told you, in your maths, you are supposed to study, differentiation this 11th itself, but you are studying only in your 12th standard. Okay, so because of this, that's a confusion. So for now, don't worry about it. Okay, take it down. We'll see. Whichever problems which does not involve these things, we can do it. This one I told you, whenever you see cos or sine and a combination of plus minus, then it is simple harmonic motion. So I returned as not simple motion. Sine and cos. So differentiate this. Okay, write this. Okay, again, as I told you here, right, like this, you have to really do the differentiation 2 times to find whether acceleration can be written in terms of displacement. So only if you are able to write this, you will be able to, call it as simple harmonic motion. So as I told you, I will do some, Excel simulations for this. You cannot imagine this unless I show you some Excel simulations. So I'll try this later. So what you can do is you can plot cos omega t, you can plot cos 2 omega t or 3 omega t, whatever is given here. And then you can add all these 3 things. So when you add it, you will see the curve. So depending upon the curve, how it looks like, I can say whether it is simple harmonic motion or not. For now, I can simply say only the mathematical method. So in the mathematical method, I don't think this will be, this will be coming like this, which means this will be periodic but not simple harmonic motion. Exponential, whenever it is exponential, it is not periodic, right? So what this means is, it's again, basics from mathematics. So the exponential curve will look something like this. Whereas if you see the sine or cos curves, it looks something like this. So what I'm trying to say here is this is a periodic function. So after a certain time, it will repeat itself. Whereas here, after a certain time, it's not going to repeat itself. So this is not periodic. So whenever you see something like, exponential function, you can say non-periodic. Uzma, does that make sense?
Yes, sir.
Sine and cos, you see, it's kind of repeating. Whereas here, this will not repeat. It will just keep on going like this. So that's why, whenever you see exponential curve, it will be like this. That's non-periodic. This is also same thing. It's not like so this is something like your quadratic equation. Quadratic equation means what will be the curve if you plot it. 10th standard you have done this. When you plot a quadratic equation, what does the graph look like? Straight line or a parabola?
Parabola.
Parabola, yeah. So since it is a parabola, right? So the curve is going to look something like this. So what do you think? After a certain time, will it repeat or it just keeps on going like this?
It keeps on going.
Which means is it periodic or non-periodic?
Not periodic.
Non.
Okay, very good. So that means whenever you see exponential or parabola, something like this, you can definitely say it is non-periodic. Whenever you see sine or cos, right, it will be periodic. Whenever you see sine squared or cos squared, it is periodic, but it is not simple harmonic. And then this one, when you have a combination of cos 3 omega t, cos 5 omega t, it is periodic, but it is not simple harmonic. Why? I cannot, tell unless I show you the mathematical working. But even if I show you the mathematical working now, you don't know this differentiation formulas. There's something called UV method. So you keep the U as such and differentiate B, and then plus, so it's like U dV plus P du. Okay. I don't want to confuse you. So whenever you see sine or cos like this, it is periodic. Whenever you see something like this, it is periodic but not such. If you see only sine or cos, definitely it's a period. Okay, so take it down properly. Very, very mathematical question. Okay, so unfortunately, you cannot do this 100%, without your maths knowledge. Okay, so the first three problems, I will leave it to you. Finish these things. Let's try 14.7 or 14.8. Looks like 14.8 is the easy one. So let's try that. Spring balance has a scale that reads from 0 to 50 kg. The length of the scale is 20 centimeter. Okay. Body suspended from this balance when displaced and released oscillates with a period of 0.6 seconds. That means oscillates with the time period of 0.6 seconds. Right, so it's kind of moving up and down. The spring balance means there'll be a scale shown over here. So when you remove this mass, this pointer will be pointing at 0. So as you keep on putting more and more mass, what will happen? This pointer will come down, which means it will show you as 1 kg, 2 kg, so 10 kg, 20 kg, 30 kg, 40, 50 kg. So they said it will go up to 50 kg. What is the weight of the body? We studied a formula F is equal to Kx. Length of the scale is 20 centimeter. So the total length of the scale is 20 centimeter. The total measurement which you can do with the scale is only 50 kg. I mean, this length is 20 centimeter. So what this means is, what this tells me is, when this is 20 centimeter, this will be 50 kg. So it means 50 kg into gravity. Instead of 9.8, just for simplicity, I'm going to take this. K into x is 20 centimeters. So 20 divided by 100. So from this, I can calculate the K. So 0, 0 cancels. 10 comes on this side, so it will become 5,000. So K is equal to 5,000 approximately. Newton per meter. What is the weight of the body for the object which is doing 0.6 seconds time period? So time period is equal to T is equal to 2 pi by omega. Omega is equal to square root of K by X. Okay. So, sorry, square root of K by M. So, somewhere you have studied this. Okay, so take it down. Omega is equal to square root of K by M. K is the spring constant, M is the mass attached. Okay. So, as the mass increases, this value will decrease because the inertia is increasing, which means the frequency will be decreased.
Sir,
Yeah,
I have a doubt.
yeah.
When the K value will be 2500.
Don't make a mistake. Yeah, 2 is coming on this side, so yeah, okay. So I didn't think about this. You are right. So as the mass increases, omega is equal to square root of K by M. Let me check the formula here. Remember this. I am looking at page number 37 in your handbook. So let's see if I see some formula. Omega is equal to K by M. Yeah, it's correct. Square root of K by M. Okay, it's there in spring calculations. Okay. So it means T is equal to 2 pi by omega. So 2 pi by omega will be square root of K by M. So square root of M by K. Take this. So K is known. Mass is what they're asking, right? So if you calculate the mass, from that you can calculate the weight. The time period is given as 0.6 seconds. So after that, it is your department. Do the math and find out the M value. So go through it and tell me if you have any difficulty. So basically what they are saying is the total scale is 20 centimeter. The total measurement is 50 kg, which means I can connect 20 to 50 centimeters and calculate the K. 2 pi by omega. Omega is square root of K by M. So that's the standard formula you should remember from the derivation. Okay. So from that I can calculate this T formula. So that means this is known, which means I can calculate the mass. Once I know the mass, multiply by 9.8, I should get the weight. Ashwant, okay?
Sir,
Following?
yes, sir.
Okay. Mithun, what about you?
Following.
Following? Okay. Let's try 14.9. A spring having with the spring constant 1200 Newton per meter is mounted on a horizontal table as shown. A mass of 3 kg is attached to the free end of the spring. Mass is then pulled sideways to a distance of 2 centimeter and then released. Determine the frequency of the oscillations. So it means you have the mass here. I think they said frictionless. They didn't say anything about the friction, so I'm going to assume that it's a frictionless table. K is given. So it's going to go, back and forth like this. Mass is then pulled sideways to a distance of 2 centimeter and released. Determine the frequency of the oscillation, maximum acceleration of the mass, maximum speed of the mass. Okay. F is equal to kx, right? K is given. Displacement is given. So you know that when it is at the maximum position, extreme position, the velocity will be 0. But when it is passing through the mean position, the velocity will be maximum. This you should know from the basics. Velocity maximum, we said something like, if you go back and do the formulas, right? Check the formulas. We said V is equal to A omega cos omega t. Then we did a derivation where omega was kept outside. Then we derived it as a square minus x square. Okay, cos will be written as square root of 1 minus sin square. So a will go inside, so it will become a square into minus a into sin square. A into sin square is not, a square into sin square is nothing but x square, right? So this will be your positive. But then actually we want only V max, which means whatever is in front of this cos omega t, that is your V max. So how do we find omega? Omega is equal to, just now we did this, K by M. So K is given, mass is given, which means I can find the omega. So the omega can be substituted here. Amplitude is 2 centimeter, which means 2 divided by 100. So that's your amplitude. So do the math, you will get the V max. So take it down, you can do it later, check the answers. So that's your V max, maximum speed of the mass. So that will be the third part. I could have told you that V max is equal to A omega, but you have to remember from the derivation. You would have got A omega cos omega t. So whatever is in front of cos or sin, that is what is the maximum value. That's your V max. That will happen in the mean position. Maximum acceleration of the mass will happen at the extreme locations. Why? Because acceleration. Okay, for frequency of oscillation, it's easy. So I will finish the first part. Frequency is nothing but nu. So nu is equal to 2 pi omega. Okay, t is equal to 2 pi by omega. So omega by 2 pi. Don't make a mistake here. So it's not 2 pi. Omega is equal to 2 pi nu. So nu is equal to omega by 2 pi. If that is confusing, then you should know T is equal to 2 pi by omega, which means frequency is equal to 1 by T time period. 1 by T is nothing but omega by 2 pi. Either you have to know this formula or this formula. So you know omega from this. You know 2 pi, which means you can calculate the frequency. What about the second part? Second part, maximum acceleration. Acceleration is equal to minus omega squared into x. So the maximum acceleration will happen in the extreme location. Okay. Everyone listen carefully. Why extreme location? As x increases, acceleration also increases, which means the maximum acceleration will happen in maximum displacement. Everyone okay with that? Ankita, do you follow?
Yes, sir.
Maximum acceleration at maximum displacement. That means maximum displacement is 2 centimeter. So A is equal to minus omega, you calculated it from here. So omega squared into x is 2 centimeters. So 2 by. So calculate the omega from here on. So you see the omega calculation is required for all the other things also. That's all. So if you have any doubts, please clarify. So it's a direct formula. It looks like confusing more things. It's all direct formulas. Okay, let's see what else we can do. My battery is kind of running out. Let me connect the power. Okay. So Ashwant, do you have any other specific problems which you tried but you had difficulty, something like that? Ashwant, talking to you. No response at all. Okay, wasted time. Let's see what else can I do. Okay, we can try this one. 14 quantum distribution of the mass with the smallest unstretched as positive direction. X axis is x as a function of time t for the oscillating mass. If at the moment start the stopwatch is equal to 0, mass is the mean position, the maximum stretch position, and the maximum compressed position. What way do these functions for such and because of nature, frequency, and amplitude or in the initial phase? Okay, this is an interesting question. Maybe we can try this 15.10. So what they are saying is, in the previous question which we did, let us take the position of the mass. The spring is unstretched. It means this is unstretched position, so the mass is here. As x is equal to 0. So this is taken as x is equal to 0. Left to right as a positive direction. So this is positive direction. Which means compressing this side, it will become negative. Give x as a function of time t for the oscillating mass. If at the moment we start the stopwatch, t is equal to 0. So when the mass is at the mean position. So when it is at the mean position, so if you take t is equal to 0, right? Can anyone tell me, should the graph start like this? Or should the graph start like this? So this is your displacement, this is your time, this is your Which one?
I think the second one, sir.
Second one. Any other answers? When time t is equal to 0, you are at mean position, which means 0 position. That means it should be this one, I think, sine, not this cos. Do you agree or not?
Yes.
That means when time t is equal to 0, displacement is 0. Suppose if you had started from here, which is the next question, maximum stretch position, then you could have taken the cos like this. So for the B part, I would have started at the maximum stretch position and maximum compressed position. So stretch position means the spring is stretched like this. So from the mean position, right, it is stretched like this. So it means it's in the positive displacement, which means you should start the curve something like this. And this is maximum, this is 0. This is 0, this will be maximum. This is maximum, this will be coming to 0. This is 0, this will be maximum. Okay, so this will be cos. So this will be sine. This will be cos. C is at the maximum compressed position. What do you mean by compressed position? The spring is something like this. Of course, it has to be symmetric, right? So if this was 5 centimeters this side it should also be 5 centimeters. Again, I'm just giving some simple numbers. Don't take down the 5 centimeters. So if it is already at the negative point, right, the curve should start from negative. So that means it should start from here. In which case I would call it as negative cos. So they asked you to give the function of time, x as a function of time. So that means x is equal to amplitude into sine omega t. What is amplitude? We should take it from the previous question. So previous question, what do we have? 2 centimeter, right? Remember, we moved it by 2 centimeter. So that means this can be written as x is equal to 2 centimeter sine omega. So if you write this as centimeter, this entire thing is in centimeter. So B part, this is cos. So that means x is equal to 2 cos omega. C part, x is equal to minus 2 cos omega. Anybody not following this? This is sine, this is cos, this is minus cos. Because when time t is equal to 0, it is at negative displacement. So when I substitute t is equal to 0, cos 0 will become 1, so it will become minus 2, which means it will be here. Ankita, okay?
Yes, sir.
Ashwant,
Yes, sir.
sleeping. Earlier I asked you a question, there was no response.
I didn't hear properly, sir. Voice was breaking.
Okay, so we talked about mean position, maximum stretch position, maximum compressed position. In what way do these functions for a section differ from each other in frequency, in amplitude, and initial phase? What do you think? Does the amplitude change between this and this? It's the same everywhere, right? Do you agree?
Yes,
Yes.
No?
Yes, sir.
Amplitude is same. What about frequency? Frequency is also same. Okay.
Yes, sir.
What is changing is only the starting point. So the starting point means here the initial phase is 0. Here the initial phase is 90 degree. Here the initial phase is minus 90 degree, something like that. You know, it's supposed to start from here. So this is minus 90. This is plus 90. So the initial phase alone is changing. Okay. So take it down. Frequency and amplitude are same. The initial phase alone changes. I simply put omega, but in the book, you know, in the question they have said from the previous question, which means you have to calculate the omega from the previous question and substitute the omega. Okay, let's see. 14.11 is also a very interesting question. These are all easy questions, okay? So I'm just focusing on the somewhat easy and medium. Okay, so when you get some practice, definitely you will be able to do it in the exam. If you don't get this practice, definitely you will not be able to write in the exam. I think most schools will have problems in oscillations, so I think that's why Ashwant was also asking. So because 14.25 correspond to C. Circular motion, the radius of the circle, the period of revolution, initial position, the sense of revolution, clockwise or anti-clockwise are indicated in each figure. Obtain the corresponding simple harmonic motions of the X projections of the radius vector of the revolving particle P in each case. This I told you in the theory discussion, right? What did I say? When you start spinning particle like this. So let's take the first one. Okay. Right. When the particle is here, the shadow in the screen, right? When you put a light from here, the shadow will be here. The particle is here, the shadow will be here. And the particle is here, the shadow will be here. The particle is here, the shadow will be here. The particle is here, the shadow is here, which means start from here, go here, and then come back here. Okay, so it means that's why I told you there is a perfect connection between circular motion and simple harmonic motion. So it's kind of going back. That's why you see sin omega t, cos omega t. This radius they said 3 centimeter. If I say this is 3 centimeter, you can imagine that this is also going to be 3 centimeter. I mean, that is where I'm at. They said the time period is 2 seconds. So if I say time period is 2 seconds, I can say omega is equal to 2 pi by t. 2 cancels, so omega will be pi. So I know the amplitude, which is A is equal to 3 centimeter. I know the omega is pi. Okay. Starting position, they have given this as t is equal to 0 here. Okay, so I think they are meaning this point. When you say the starting point is here, right? What we are trying to say here is, listen carefully, very, very simple. At this point, I can say y is equal to a sin omega t. Amplitude is 3 centimeter. Sin omega t is sin pi t. I can write it like this, but it may be correct or it may be wrong. Why? Because depending upon the starting point, whether it starts here or here, right? So Uzma, tell me, if you start from here, mean position, will it be sin or cos? Uzma, sleeping?
No, sir. I think it will be sine.
Sin. If you start from extreme position, right? The graph will start from a already at a extreme position, which means it will look like a cos curve. So it means this will be sine. Okay. Here you see the curve is kind of, everyone listen carefully. When you start rotating in the clockwise direction like this, you are starting from here, t is equal to 0. So are you going in the negative direction or are you going in the positive direction? The oscillation. Ankita, tell me. When you start rotating this, will you be going this way or will you be going this way? Towards left or right? No answers. Left. Okay. Mithun, tell me, towards left, is it positive or negative?
Negative.
Negative. Which means you know that when you start from the mean position, you should take sine. But since it is going in the negative direction, right? So the curve is not going to look something like this. Why? Because here the displacement is going in the positive direction. Since it is initially itself it's going in the negative direction, it looks something like this, which means it's a negative of the sine curve. So that means you should put y is equal to minus 3 sine pi t. And don't forget you should write it as centimeter. Why? Because this is in centimeter, which means we should also be in centimeter. So second one, I'm going to leave it as a homework. So you have to ask yourself, calculate the omega from this value. From the radius, you should know what is the amplitude, which means you can tell whether it is y is equal to a sin omega t or cos omega t, depending upon the starting point. So since it is starting from the extreme position, right? So Ashwant, can you tell me, will it be cos or sin?
Sine.
sir, still you are not understood the concept. If you start from mean position, the time when time t is equal to 0, the displacement is 0. You are here. When you start from extreme position, like a pendulum starting from here, when time t is equal to 0, what is the displacement? Is it 0 or you already have a displacement?
0, sir.
No, sir, you have not understood anything here. X is equal to 0. This is the mean position. So when you leave the pendulum from here, tell me, do you already have some displacement or not?
So there's already a displacement.
So that means when you already have a displacement, if you take sine curve, what will happen? This will be saying displacement is 0 and time t is equal to 0. So that's why sine curve is wrong for this. So we should take a cos curve. But either the cos curve can be starting like this, or it can be starting from negative. So that you have to determine from the diagram. So as you are starting from here, you are going this way, which means you are going in the positive direction. So the image will be seen here and then it will be here, which means it's moving this way. So it's moving this way means displacement, it's coming towards 0. So the displacement is initially negative, right? And then it is coming towards 0. So which one do you think will be appropriate? 1 or 2? Initially the displacement is positive or negative? It's on this end. Mithun?
Negative.
Negative, very good. So it means you have the ball starting from here and then you are moving this way, okay? Which means it should be cos and then it's kind of, starting from negative means you should put a minus. That means y is equal to minus a cos omega t. It doesn't matter where it's moving. Yeah, so that means displacement is 2 centimeter, I think, right? Displacement was 3 centimeter or 2 centimeter, 2 meters. 2 meters means amplitude I should put as 2 meters. Cos omega t. Omega is, you have to calculate from t. So omega is equal to 2 pi by t. 2 pi by 4, which means it will become pi by 2. So that means omega is pi by 2. So cos pi by 2 into t. So that will be the answer. This will be in meters. Because here this is in meters, so this will also be in meters. Anybody not following? Instead of giving a homework, I directly did this. Copying everything. Any doubts here? Uzma following everything?
Yes, sir.
Okay, so it's already time. So what I'm thinking is, so next class, what do you want me to do? Continue with oscillations, or you want me to do kinetic theory? Maybe we can do some more problems from oscillations here. Okay. So and then we can some of the theory derivation type of numerical. I already did it in the theory. Okay, go back and check it. These things are already done. Ashwin, do you follow what I'm saying?
Yes, sir.
Some of the theory-based numerical, right? Derivation. I've already done it in the theory, so go back and check it. It's already there in the hand.
Okay.
Okay, so some of the other things we can do some more problems in the next class. And then, as time permits, maybe I'll do 5 more problems in oscillations and then go to kinetic theory. Is that okay, everyone?
Yes, sir.
Anybody thinking, sir, instead of kinetic theory, we would like to do waves problems because they ask a lot of questions on waves in school? Anybody like that? Okay, in that case, I'll do kinetic theory. Okay, and then we'll go to waves. Okay, thank you all. Bye.
Thank you.
Thank you, sir.